Before we begin, a quick and important disclaimer. The information provided in this video is for educational and informational purposes only. It is not intended to be a substitute for professional financial or career advice. Always seek the guidance of a qualified professional with any questions you may have regarding your personal career path or financial situation. The salaries and job market data discussed represent averages and can vary significantly based on location, experience, and individual skill sets. There is a gold rush happening in America right now, but it's not for a yellow medal you can hold in your hand. It's for a skill so valuable, so in demand, that companies from Wall Street banks to Midwest farming conglomerates are paying salaries of $150,000, $200,000, even $300,000 a year to people who have it. And the most shocking part? Many of these people don't have a computer science degree from a fancy university. Some of them were working as project managers, truck drivers, or graphic designers just a couple of years ago. They saw an opportunity, a massive shift in the economy that almost no one on the street is talking about, and they jumped on it. This video is your wake-up call, because that same opportunity is sitting right in front of you right now. And over the next few minutes, I'm going to pull back the curtain on the single biggest wealth-generating career trend in the United States today: cloud computing. By the end of this presentation, you will understand the three fundamental forces that are causing these salaries to absolutely explode. You will know why this isn't some temporary tech fad like the dot-com bubble, but a permanent structural change in how every business in the world operates. And most importantly, you'll see the clear, undeniable path that thousands of regular Americans are taking to claim their piece of this multi-trillion-dollar pie. We're not talking about vague theories. We're talking about the specific skills, the most valuable certifications, and the exact job titles that are commanding these life-changing incomes. Let me tell you about a guy named David. A few years ago, David was a logistics manager for a national retail chain. He was good at his job. He made about $65,000 a year, had decent benefits, but he felt a constant low-grade anxiety. He saw the writing on the wall. Every quarter, his company was closing more physical stores. Their online competition, a company that seemed to be able to do everything faster, cheaper, and better, was eating their lunch. David felt like he was on a slowly sinking ship. He was in his mid-30s, had a mortgage, a family, and the idea of his job disappearing was terrifying. He felt trapped. He thought the tech boom had passed him by. He didn't know how to code in 10 different languages. He felt like he'd missed the boat. Then, one day, his company announced a massive new initiative. They called it a digital transformation. They were moving all their data, their inventory systems, their entire online store, everything, to the cloud. David had heard the term, but it was just marketing jargon to him, an abstract buzzword. But as he was forced to learn about it for his job, a light bulb went off. He realized the cloud wasn't just some fluffy term. It was the engine. It was the invisible infrastructure that was powering his competitors' success. It was the reason they could scale up for Black Friday without their website crashing. It was the reason they could analyze customer data in seconds to offer personalized deals. The very force that was threatening his job was also the biggest opportunity he had ever seen. So what is this cloud that turned David's career around and is creating a new class of high-earning professionals? Forget the confusing technical diagrams. The concept is actually incredibly simple. Think about it like this. 100 years ago, if you wanted to build a big factory, you first had to build a power plant right next to it. You had to hire engineers, buy generators, manage the fuel supply. It was a massive, expensive, and complicated undertaking just to get electricity. Your core business was making widgets, but you had to become an expert in power generation first. Then, the electrical grid was invented. Suddenly, you could just plug your factory into a wall, pay a monthly bill, and get all the power you needed. You could focus on what you were actually good at, making widgets. You could scale up or down instantly, paying only for the electricity you used. The cloud is the electrical grid for the 21st century. For decades, if a company wanted to launch a website or build an application, they first had to build their own digital power plant. They had to buy massive, expensive computer servers, rent space in a secure building, hire a whole team to manage the cooling, the networking, the security, the software updates. It was a multi-million-dollar headache. Companies like Amazon, Google, and Microsoft saw this and said, "This is insane." They had already built the biggest, most powerful, most efficient computer networks in human history for their own businesses. So they started renting out access to their infrastructure. They built the digital power grid. Now, a startup in a garage in Omaha, Nebraska, can access the exact same world-class computing power as Netflix or the CIA, and they can do it with a credit card. They pay only for what they use, just like a utility bill. They can go from 10 users to 10 million users overnight, and the system just handles it. This isn't just a small improvement. This is a revolution. It has unleashed a tidal wave of innovation. Every single app on your phone, from Uber to Spotify to DoorDash, it runs on the cloud. The movie you streamed last night? Delivered from the cloud. The artificial intelligence that's changing the world? It's being trained on massive supercomputers in the cloud. The entire global economy is being rebuilt on top of this new foundation. And this brings us to the core of the salary explosion. We've just undergone the fastest and most widespread technological migration in history. Think about it. In the last decade, millions of businesses across America, from the smallest mom-and-pop shop to the largest Fortune 500 giants, have all realized at the same time: we have to get on the cloud. It's no longer a choice. It's a matter of survival. If you're not on the cloud, your competition is, and they are faster, more agile, and more data-driven than you. It's an extinction-level event for companies that can't adapt. This has created an unprecedented demand shock in the labor market. Suddenly, every company needs people who understand how this new digital grid works. They need people who can act as the architects, designing the blueprints for how their company will move to the cloud. They need engineers who can build the digital pipelines to make it happen. They need security experts to guard the gates of this new digital infrastructure. They need specialists who know how to manage the costs, so the utility bill doesn't spiral out of control. But here's the problem for them and the opportunity for you. The supply of people with these skills is tiny. The technology is so new that universities are years behind. Traditional IT departments were built for the old world of managing physical servers in a basement. They don't have the training for this new paradigm. So we have this massive economy-wide demand hitting a brick wall of incredibly scarce supply. And what happens in any market when demand skyrockets and supply is flat? The price goes through the roof. In this case, the price is the salary that companies are willing to pay for cloud talent. They are in a desperate bidding war for anyone who can help them make this critical transition. They're not just competing with other companies in their industry, they're competing with Amazon, Google, and Microsoft themselves, who are also hiring these same people by the thousands. This is the perfect economic storm for anyone with the right skills. And it's why we're seeing salary offers that seem almost unbelievable. It's not hype, simple raw supply and demand. So let's break that down with a simple analogy. Imagine a small, quiet town. It has 100 houses and 100 families live there. Everything is stable. The price of a house is predictable. Now imagine that 3 of the world's largest companies simultaneously announce they are building massive headquarters in that same small town. Suddenly, thousands of high-paid employees need a place to live, but there are still only 100 houses. What happens to the price of those houses? It doesn't just go up. It goes nuclear. Bidding wars erupt. People are offering double, triple the asking price sight unseen. That quiet town's housing market becomes the hottest in the country overnight. In this analogy, the quiet town is the global talent pool. The houses are skilled cloud professionals. And those massive companies, that's not just Amazon, Google, and Microsoft. It's every single company in every single industry all at once deciding they need to move into the cloud, and they needed to do it yesterday. The demand isn't just high. It's a frantic, desperate land grab for talent. So what's fueling this unprecedented corporate migration? Why is every business from Wall Street banks to Midwest farming cooperatives suddenly in a panic to hire cloud engineers? It boils down to 3 revolutionary forces that are reshaping our entire economy. The first force is the Great Digital Transformation. This is a fancy term for a very simple reality. To survive in the 21st century, every company must become a technology company. Think about it. A bank is no longer just a brick-and-mortar building with a vault. It's a mobile app. It's a data analytics engine that approves loans in seconds. It's a cybersecurity firm protecting your life savings from hackers. All of that, the app, the data, the security, runs on the cloud. Or consider a company like Domino's Pizza. You might think they sell pizza, but really, they're a logistics and technology company that just happens to deliver a food product. Their online ordering platform, their GPS pizza tracker, their supply chain management that ensures every store has enough cheese and pepperoni. It's a massive, complex technological operation. That entire operation is powered by the cloud. Without it, they'd be crushed by competitors like DoorDash and Uber Eats, which were born in the cloud from day one. This is happening everywhere. Car companies are now software companies that build electric vehicles around a central operating system. Healthcare providers are data science companies using cloud computing to predict disease outbreaks and personalize patient care. Even agriculture is going high-tech, with farms using cloud-connected drones and IoT sensors to monitor crop health and optimize water usage. The cloud is no longer a niche IT department concern. It is the fundamental backbone of modern business. It's the electricity, the plumbing, the very foundation upon which new value is built. And if you don't have people who can build and maintain that foundation, your entire business is at risk of collapse. That creates a deep existential level of demand. The second force, riding on the back of the first, is the data tsunami. We are creating and collecting data at a rate that is almost impossible to comprehend. Every time you stream a movie, post a photo, ask Alexa for the weather, or wear a fitness tracker on your morning run, you are generating data. Your smart thermostat, your car's navigation system, the security camera on your porch, all of it is constantly feeding a torrent of information into the digital universe. The old way of doing things, buying a big server and sticking it in a closet in your office, is like trying to catch a tsunami with a bucket. It's utterly insufficient. The sheer volume, velocity, and variety of this data requires the near-infinite storage and processing power that only the cloud can provide. Companies are drowning in this data, and they know that hidden within it are the secrets to their future success. Insights into customer behavior, opportunities for new products, ways to make their operations more efficient. But that data is worthless if it's just sitting there. It needs to be collected, cleaned, stored, and analyzed by powerful computer systems. And where do those systems live? On massive cloud platforms like AWS, Azure, and Google Cloud. So every company that wants to make sense of this data gold rush needs an army of cloud data engineers, data architects, and data scientists to build the pipelines and platforms to manage it all. The more data we create, the more cloud experts we need. And we are creating more data every single second. But the third force is the one that has truly thrown gasoline on the fire. It's the one you've been hearing about everywhere. The artificial intelligence and machine learning gold rush. AI models, especially the large language models like the one that powers ChatGPT, are not just regular computer programs. They are computational monsters. Training a single state-of-the-art AI model can require more computing power than a small city. It involves processing trillions of data points using thousands of specialized computer chips, running simultaneously for weeks or even months. You cannot do this in your company's basement. It is physically and financially impossible for almost any organization on Earth to build and maintain the kind of infrastructure needed to compete in the AI race. The only way to access this level of power is to rent it from the cloud providers. They are the ones who have spent billions of dollars building the hyperscale data centers, the custom AI chips, and the sophisticated software required to train and deploy these world-changing models. So now, every startup and every Fortune 500 company is scrambling to build their own AI features. They want to create their own chatbots, their own image generators, their own predictive analytics tools. And to do any of that, the absolute first step is to build on the cloud. This has created a brand new hyper-accelerated wave of demand for a very specific type of cloud professional, the machine learning engineer, the AI infrastructure specialist. These are the people who can bridge the gap between the theoretical world of AI algorithms and the practical world of cloud infrastructure. They are the ones who can build the digital factories where AI is made. And right now, they are among the most sought-after and highest-paid professionals on the planet. So you have this trifecta of overwhelming demand. Every company needs to be a tech company, every company is drowning in data, and every company wants to win the AI race. All three roads lead directly to the cloud. This explains the demand side of the equation. But what about the supply? Why aren't there enough people to fill these roles? The problem is that while the demand for cloud skills exploded almost overnight, the supply of talent grows at a snail's pace. First, this stuff is genuinely difficult. It's a complex and ever-changing field that sits at the intersection of software development, network engineering, database administration, and cybersecurity. It's not a single skill, it's a whole collection of skills. You have to understand how to write code, how to design resilient and scalable systems, how to manage massive datasets, and how to secure everything against a constant barrage of threats. The learning curve is steep and it filters out a huge number of people. Second, the technology is a relentlessly moving target. The major cloud platforms release hundreds of new services and thousands of updates every single year. The skills that were cutting edge 2 years ago might be legacy technology today. This means that to stay relevant, a cloud professional has to be committed to constant, lifelong learning. It's like being a doctor who has to learn entirely new forms of surgery every 6 months. It takes a specific kind of person to thrive in that environment, which naturally limits the size of the talent pool. Finally, our traditional education systems are failing to keep up. A 4-year computer science degree is fantastic for learning timeless fundamentals, but it's often years behind the fast-moving trends of the industry. A university curriculum can take years to be designed and approved. By the time a course on a specific cloud technology is offered to students, the industry may have already moved on to the next big thing. This creates a massive gap between what graduates know and what companies desperately need, a gap that can only be filled by intensive self-study, boot camps, and on-the-job training. So you have this perfect storm, an unstoppable tidal wave of demand driven by the most powerful economic forces of our time, crashing into an incredibly small and slow-to-grow pool of qualified talent. When infinite demand meets finite supply, the price, in this case the salary, has nowhere to go but up, and up, and up. So let's talk about that demand. It's not just big. It's a fundamental rewiring of the entire American economy. For the last century, the backbone of a successful business was physical. Factories, storefronts, supply chains. Today, the backbone is digital, and it runs on the cloud. This isn't some niche tech trend. This is everything everywhere all at once. Think about the last pizza you ordered. You probably used an app. That app didn't live on a dusty server in the back of your local Domino's. It lived on the cloud. The system that tracked your order, that optimized the delivery driver's route, that processed your payment, that stored your preferences for next time, all of it cloud. Domino's isn't a pizza company with a tech department anymore. They are a technology company that sells pizza. Their stock price over the last decade has outperformed Google and Apple at times, not because their pepperoni got better, but because their code got better. Their ability to leverage the cloud became their primary competitive advantage. Now multiply that by, well, every company. The bank you use? It's not a building with a vault. It's a financial technology firm whose most valuable asset is its cloud-based data platform. The car you drive? It's no longer just a mechanical machine. It's a rolling data center on wheels, constantly sending terabytes of information about engine performance, traffic patterns, and your driving habits back to servers in the cloud. Ford, General Motors, Tesla, they're not just competing on horsepower anymore. They're competing on processing power. They're hiring more cloud architects than mechanical engineers because the future of the automobile isn't in the engine block. It's in the data block. This is the great transformation. Every company, whether they sell coffee, tractors, or insurance, is waking up to the same terrifying and exhilarating realization. If they don't become a tech company, they will be replaced by one. And the entry ticket to becoming a tech company, the foundational platform upon which this entire revolution is built, is the cloud. It's the new electricity. It's the new factory floor. It's the new real estate. You either build on it or you become a fossil. This creates a frantic, gold rush-style scramble for cloud infrastructure. But it's not just about renting server space. It's about what you do with it. And what every company is doing is collecting a tsunami of data. Every click, every search, every video view, every credit card swipe, every single interaction you have with the digital world is a drop of water in an ever-expanding ocean of data. The International Data Corporation estimates that the amount of data created globally will more than double in the next 4 years alone. Where does all that data go? It doesn't just evaporate. It has to be stored, secured, organized, and analyzed. And the only place on Earth capable of handling that scale is the public cloud, the massive, globe-spanning data centers of Amazon, Microsoft, and Google. This data isn't just sitting there either. It's the new oil. It's the raw material for the most powerful technology humanity has ever created, artificial intelligence. And this is the real accelerant. This is the gallon of gasoline thrown on an already raging fire. AI is not a product you buy off a shelf. It is a ravenous beast that feeds on two things: data and computing power. And it needs biblical amounts of both. Training a large language model like the one that powers ChatGPT doesn't happen on a laptop. It requires a supercomputer, a virtual fleet of tens of thousands of the world's most powerful processors, all running in perfect sync, sometimes for months on end, all hosted, you guessed it, in the cloud. Every time a startup announces a new AI breakthrough, every time a Fortune 500 company launches an AI-powered initiative, what they are really announcing is a massive multi-million-dollar investment in cloud computing. They are placing a huge bet that they can turn raw data into intelligent action. And the casino where all these bets are being placed is the cloud. This has created a viciously competitive feedback loop. Companies need AI to stay relevant. AI needs data and massive compute. Data and massive compute can only be found at scale in the cloud. Therefore, every single dollar of the hundreds of billions being poured into the AI revolution is, fundamentally, a dollar being poured into the cloud ecosystem. This brings us to the most critical economic shift of all, the one that underpins this entire salary explosion. It's the move from owning to renting. For decades, if a company needed serious computing power, they had to build a data center. This was a nightmare. It meant spending millions of dollars on real estate, on servers, on cooling systems, on networking gear, on physical security, and on an army of IT staff to keep the lights on. It was slow, it was incredibly expensive, and it was a massive capital risk. You had to guess how much capacity you'd need 3 years from now. And if you guessed wrong, you were either wasting millions on idle machines or you were crashing because you couldn't handle customer demand. The cloud flipped that model on its head. Suddenly, with a credit card and a few clicks, you could rent a virtual supercomputer from Amazon, Microsoft, or Google. You didn't have to buy the hardware. You didn't have to manage the cooling. You paid only for what you used by the second. Need more power for Black Friday? You scale up instantly. Is business slow on a Tuesday morning? You scale down automatically. This is a change as profound as the shift from building your own power plant to plugging into the electrical grid. It democratized access to elite-level computing. A teenager in their garage could now access the same world-class infrastructure as the Pentagon. This unleashed a wave of innovation unlike anything we have ever seen. Companies like Netflix, Airbnb, and Stripe couldn't exist without the cloud. They were able to grow from tiny startups to global giants in record time because they didn't have to waste time and money building their own infrastructure. They could focus on one thing, building a better product. So what happens when every single company in America, from the smallest startup to the largest legacy corporation, simultaneously decides to abandon their own expensive, clunky data centers and migrate their entire digital operations to this new, powerful and efficient computing grid? You get a stampede, a once-in-a-generation migration of trillions of dollars in IT spending, a tidal wave of demand for cloud services that is so large, so sudden, and so all-encompassing that it has completely overwhelmed the market. Companies aren't just wanting to move to the cloud, they are forced to. It's a matter of survival. Their competitors are doing it, gaining speed, agility, and power that is impossible to compete with using old technology. The demand, therefore, isn't just a number on a chart. It is a force of economic nature. It's the sum of every business trying to survive digital disruption. It's the weight of the entire data economy shifting its foundation. It's the unquenchable thirst of the AI revolution for more power. It is, for all practical purposes, infinite. But here's the problem. The infrastructure, the virtual machines, the storage, that part is infinitely scalable. Amazon and Google can always build more data centers. But the people, the human beings with the incredibly specialized, complex skills required to architect, build, secure, and manage these systems, they can't be built in a factory. They can't be scaled up with the click of a button. And that is where the other side of our economic equation comes in. The side that turns a hot job market into a historic salary explosion. The supply. The supply. It's a simple word, but it represents the most critical, most misunderstood, and most valuable part of this entire economic earthquake. Because the problem isn't just a shortage of people. It's a shortage of a very specific kind of person. We're not just looking for more bodies to fill chairs. We're in a desperate, nationwide hunt for wizards, for translators, for people who can speak the language of business and the language of machines, often in the same sentence. To understand why this supply is so catastrophically low, you have to understand that the cloud isn't a single skill. It's not like learning to be a plumber or an electrician, where the core principles have been stable for decades. Learning the cloud is like trying to assemble a 10,000-piece puzzle that's actively on fire, while someone keeps swapping out the pieces for new ones you've never seen before. Let's start with the first reason for this shortage: the speed of light, or at least the speed of Amazon, Microsoft, and Google. In 2022 alone, Amazon Web Services, the market leader, released over 3,000 new features and services. 3,000. That's more than 8 significant updates every single day. Microsoft Azure and Google Cloud Platform are moving at a similar blistering pace. Think about what this means for a professional in the field. The cutting-edge, high-demand skill you mastered last year? It might be obsolete this year, replaced by a new managed service that does it better, faster, and cheaper. The architecture you designed for your company 2 years ago? It's likely already a legacy system, in need of modernization. This isn't a career where you learn a trade and then coast for 30 years. It's a career of perpetual learning. It's a constant, relentless sprint just to keep from falling behind. The person who was an expert in 2020 has to completely re-educate themselves to remain an expert in 2024. This dynamic acts as a massive filter. It weeds out anyone who isn't obsessively passionate, pathologically curious, and willing to dedicate their nights and weekends to staying current. The pool of available talent isn't just small. It's constantly evaporating. But speed is only half the story. The other half is complexity. And this is where most people's understanding of the cloud falls apart. A common misconception is that a cloud professional is just a superpowered IT guy or a coder who knows how to use Amazon. This is like saying a Formula One driver is just a person who knows how to use a steering wheel. The reality is that a truly valuable cloud engineer is a master of a dozen different disciplines, all at once. They have to be a network specialist, but instead of plugging in physical cables, they're designing virtual private clouds, configuring subnets, routing tables, and internet gateways that can span the entire globe, all defined in code. They have to be a security expert, but instead of just installing antivirus software, they're managing cryptographic keys, setting up intricate identity and access management policies, and ensuring every byte of data is encrypted both when it's sitting on a disk and when it's flying across the internet. They have to navigate a labyrinth of compliance standards like HIPAA for healthcare or PCI for credit cards, where one wrong click could lead to a multi-million-dollar fine. They have to be a database administrator, but they're not just managing one big server in a closet. They're deciding between a dozen different database technologies, SQL, NoSQL, graph databases, time series databases, and deploying them in configurations that are geo-redundant, meaning if an entire data center in Virginia gets wiped out by a hurricane, the application seamlessly fails over to another one in Ohio or Oregon with zero downtime. They have to be a financial analyst, constantly monitoring spending, optimizing costs, and forecasting budgets in a pay-as-you-go model where a forgotten virtual machine or a poorly written piece of code can accidentally rack up a $10,000 bill overnight. And most importantly, they have to be an architect. They have to be able to take all of these disparate pieces, the networking, the security, the databases, the computing power, the cost, and weave them together into a single cohesive system that is secure, scalable, resilient, and cost-effective. It's not about knowing what a single tool does. It's about knowing how to conduct the entire orchestra. This is the skill that is so rare it borders on mythical. It's the difference between knowing the ingredients for a cake and being a Michelin star pastry chef. This brings us to the third and perhaps most structural problem: the education gap. Our traditional systems for creating skilled workers, universities and colleges, are simply not built for this world. A 4-year computer science curriculum is often outdated by the time a student graduates. The technologies and best practices they learned as a freshman are ancient history by their senior year. The professors, brilliant as they may be in theory and algorithms, often lack the real-world, in-the-trenches experience of running massive systems on the cloud. So what about boot camps and online certifications? They're a piece of the puzzle, but they're not a silver bullet. They can teach you the fundamentals. They can help you pass a multiple-choice certification exam. And for many people, that's a fantastic entry point into the industry. But here's the harsh truth that hiring managers know all too well. A certification proves you can memorize facts. It does not prove you can solve a complex, real-world problem under pressure. It doesn't prove you can debug a critical production system at 3 a.m. with the entire company losing money every minute you're down. This creates the ultimate chicken and egg scenario. Companies desperately need people with 3 to 5 years of hands-on real-world experience. But how do you get that experience if no one will hire you without it? This is why the real war for talent isn't at the entry level. It's for the mid-level and senior engineers. The people who have survived the trials by fire. The ones who have built systems, watched them fail, and learned the hard lessons of what not to do. These individuals are the true unicorns. They are the ones who have successfully navigated the high-speed, high-complexity, low-education pipeline. So you have this perfect storm on the supply side. A field that changes so fast it makes yesterday's experts obsolete. A level of multidisciplinary complexity that demands a rare combination of skills. And an educational system that is fundamentally too slow and too theoretical to keep up with the pace of the real world. This isn't just a skills gap. It's a skills canyon. A vast, widening chasm between what American businesses need to survive and innovate, and the actual available talent pool capable of delivering it. And when you have the unstoppable force of demand we talked about earlier, crashing against the immovable object of this incredibly constricted supply, basic economics dictates what happens next. The price for crossing that chasm, the salary you have to pay to lure one of these wizards to your team, doesn't just go up, it goes vertical. It explodes. And it has created a new class of technologists with compensation packages that are starting to rival those of doctors, lawyers, and investment bankers. So who are these new titans of the digital age? They're not just IT guys. They're a new breed, a specialized force operating at the highest levels of business strategy. And they go by titles that, just 15 years ago, didn't even exist. Let's pull back the curtain on 3 of the most critical, most sought-after, and highest-paid roles in this new cloud economy: the cloud architect, the cloud security engineer, and the DevOps engineer. First, the cloud architect. Think of them as the master blueprint designer for a digital skyscraper. Before a single line of code is written, before a single server is spun up, the architect is in the room with the CEO, the CTO, the head of finance, asking the big questions. What are we trying to build? Who is it for? How many people will use it on day 1 versus day 1,000? How much can we afford to spend? And most importantly, how do we build this thing so it doesn't fall over? The architect doesn't lay the digital bricks themselves. Instead, they design the entire system. They decide, are we building on Amazon Web Services, Microsoft Azure, or Google Cloud? It's like choosing whether your skyscraper's foundation will be built on granite, sandstone, or marble. Each has different properties, costs, and long-term implications. They map out how every single piece of the company's online presence will connect. How the customer database talks to the payment processor, how the video streaming service talks to the recommendation engine, how the whole system can handle 1,000 users 1 minute and 10 million the next, all without a single hiccup. This is where the money comes from. A bad architectural decision at this stage is catastrophic. It's like designing a skyscraper with a foundation built for a 2-story house. It might work for a little while, but when the pressure comes, a viral marketing campaign, a holiday shopping rush, the entire thing collapses. A poor architecture can lead to millions in wasted cloud spending, crippling downtime that costs a fortune in lost sales, or security holes so big you could drive a truck through them. The cloud architect's job is to prevent that disaster before it ever begins. They are paid a fortune not just for what they build, but for the calamities they help the company avoid. Their decisions have a direct, massive, and immediate impact on the company's bottom line, and their compensation reflects that immense responsibility. Next, we have the cloud security engineer. If the architect is the blueprint designer, the security engineer is the head of the Secret Service, the warden of a digital Alcatraz, and the designer of a virtual Fort Knox, all rolled into one. In the old world, a company's data was a physical thing. It sat on servers in a locked room in a guarded building behind a fence. Security was about locks, cameras, and security guards. In the cloud, that data is everywhere and nowhere at once. It's sitting in a massive, anonymous data center owned by Amazon or Microsoft, somewhere in Virginia or Oregon, right next to the data of hundreds of other companies. The only thing protecting your company's crown jewels, your customer lists, your financial records, your secret product designs, is a complex web of digital defenses. And the cloud security engineer is the person who builds, maintains, and defends that web. They are professional paranoids paid to think like a hacker. They spend their days asking, how would I break into this system? They set up firewalls, encryption, and multi-factor authentication. They run constant scans for vulnerabilities. They build sophisticated monitoring systems that can detect a cyber attack in real time, the digital equivalent of a silent alarm. They are the ones who get the call at 3 a.m. when that alarm goes off, and they are expected to neutralize the threat before a single piece of data is stolen. Why is this role exploding? Because the cost of failure is astronomical. A single major data breach can cost a company hundreds of millions of dollars in fines, lawsuits, and regulatory penalties. But the real cost is the complete and utter destruction of customer trust, which can permanently cripple a brand. A cloud security engineer making $300,000 a year is a rounding error compared to the potential 10-figure cost of a breach. They are not a cost center. They are an insurance policy against corporate extinction. Finally, there's one of the most misunderstood yet vital roles: the DevOps or Site Reliability Engineer, often called an SRE. To understand what they do, imagine a Formula One racing team. You have the brilliant engineers who design the car, those are the software developers. But their design is useless if you can't build the car, get it to the track, and keep it running at 220 miles per hour without the engine exploding. The DevOps engineer is the chief of the pit crew. They build the automated, high-speed assembly line, what they call a pipeline, that takes the developer's new code and gets it out onto the live website or app in minutes, not months. In the old days, releasing new software was a terrifying all-hands-on-deck event that happened a few times a year. With the systems DevOps engineers build, companies like Amazon and Netflix can deploy new code thousands of times a day with almost no risk. This gives them an incredible competitive advantage. They can release new features, fix bugs, and respond to customer feedback at lightning speed, while their competitors are stuck in the slow lane. The SRE, a role famously pioneered at Google, is the race engineer obsessed with performance and reliability. Their job is to make sure that when the light turns green, the system doesn't just run, it flies. They live and breathe uptime. They instrument every part of the system with monitors and alerts. They are obsessed with making the service faster, more resilient, and more efficient. When a site like your favorite social media platform or online store goes down, it's the SRE team that gets paged to bring it back online. Every second of downtime for a major e-commerce company can mean millions in lost revenue. The SRE's job is to make those seconds as rare as humanly possible. These two roles, DevOps and SRE, are the engine of modern business. They are the force that enables speed, stability, and scale. They are paid so much because they directly control the two things that matter most in the digital world: the pace of innovation and the reliability of the customer experience. So you have the architect designing the city, the security engineer defending its walls, and the DevOps and SRE teams managing its highways and power grid. Each role is distinct, yet deeply interconnected, and the demand for people who can master even one of these domains is intense. But the real unicorns, the individuals who command the truly eye-watering salaries, are those who understand all three. They can design a system that is brilliant, secure, and reliable. This trifecta of skills is so rare, so difficult to cultivate, and so incredibly valuable to a modern business that it has fundamentally broken the old salary scales. But this raises a critical question. How did we get here? Why did this entire ecosystem of roles and this incredible demand seem to appear out of nowhere? It wasn't a slow evolution. It was a big bang, an explosion that created a new universe of technology. And believe it or not, it all started with an online bookstore that was just trying to solve its own Christmas shopping problem. The year is 2003. Amazon isn't the global behemoth we know today. It's a fast-growing, but still fundamentally an online bookstore. And it has a Texas-sized headache. Every November, the company would brace for impact. The holiday shopping season was like a hurricane hitting their website. Traffic would spike by 10, 20, sometimes 30 times its normal volume. To handle this, they had to build a ridiculously over-engineered, massively expensive infrastructure of servers, databases, and networking gear. They had to buy and install enough computing power to handle the single busiest minute of the year on Christmas Eve. But what happened on December 26? The hurricane would pass. The traffic would plummet back to normal. And for the next 10 months, the vast majority of that expensive, powerful server infrastructure just sat there, idle, collecting dust. It was like buying an entire fleet of snowplows for a city that only gets one blizzard a year. It was an astronomical waste of capital, a boat anchor dragging down their profits. Inside Amazon, this was a well-known, deeply frustrating problem. Teams were siloed. If a new team wanted to launch a project, say a new recommendation engine, they had to start from scratch. They'd have to order their own servers, set up their own databases, configure their own networks. It was slow, inefficient, and incredibly redundant. Every team was reinventing the same wheel, and the company was paying for dozens of different wheels that all did the same thing. Then, in a now legendary executive retreat at Jeff Bezos's house, two engineers named Benjamin Black and Chris Pinkham presented a paper. Their vision was radical. They argued that Amazon's real core competency wasn't just selling things online. It was building massive, scalable, reliable computing infrastructure. They were one of the best in the world at it, purely out of necessity. And that's when the light bulb went off. It was a moment that would fundamentally change the course of modern technology. The idea was simple, but its implications were earth-shattering. What if they could take their biggest internal weakness, this massive idle server capacity, and turn it into their greatest strength? What if they could rent out that computing power to other people? What if they could offer infrastructure itself as a service, just like you'd offer electricity or water from a utility company? This wasn't just about renting out spare servers. It was a complete philosophical shift. They decided to rebuild their entire internal infrastructure from the ground up, but with a new rule. Every single component, from data storage to computing power to databases, had to be built as a separate self-contained service. And every one of these services had to be accessible not by a human clicking a mouse, but through an application programming interface, an API. This meant other computer programs could talk to it, control it, and build on top of it. They were essentially creating a set of technology Lego bricks. One brick for storage, one for computing, one for databases, and they would let anyone in the world rent these bricks, paying only for the ones they used for as long as they used them. In 2006, Amazon Web Services, or AWS, officially launched its first two major Lego bricks. The first was S3, the simple storage service. It did one thing and did it perfectly. It stored data on the internet reliably and cheaply. The second was EC2, the elastic compute cloud. This was the real game changer. It let you rent a virtual server by the hour. Think about how insane this was. At the time, if you were a developer with an idea for a new app, your path was brutal. First, you had to convince venture capitalists to give you millions of dollars. Then you'd use that money to go buy a truckload of expensive servers from Dell or HP. You'd have to find a data center to house them, sign a long-term lease, hire network engineers to connect them to the internet, and system administrators to maintain them. This process could take 6 months and burn through your entire budget before you'd even written a single line of your actual application's code. The barrier to entry for innovation was a 10-foot-high wall of steel and cash. AWS took a sledgehammer to that wall. Suddenly, 2 college students in a dorm room with a $15 a month credit card limit could do what previously took a team of engineers and millions in funding. With a few clicks, they could launch a virtual server on EC2. They could store user photos in S3 for pennies. They didn't need to predict their traffic for the next year. They could just add more servers if their app went viral, and shut them down if it didn't. The cost of failure dropped to virtually zero. The established tech world, Microsoft, Oracle, IBM, they all scoffed. They looked at Amazon and saw a bookstore. What does a retailer know about enterprise computing? They sneered. They completely missed the point. They were selling expensive, monolithic products. Amazon was selling raw, flexible, pay-as-you-go utility. But the startup world? They got it instantly. This was the Cambrian explosion for a new generation of tech companies. Companies like Dropbox, which needed to store petabytes of user files. Or Airbnb, which needed to handle massive, spiky traffic as people searched for vacation rentals. And most famously, Netflix. Netflix realized that running their own data centers was a distraction from their core business of streaming movies. In a move that was considered corporate suicide at the time, they decided to shut down all of their own data centers and go all in on AWS. They bet their entire company on the cloud. This mass migration, this gold rush to the cloud, created a vacuum, a massive gaping hole in the job market. All of these new companies, and even older companies starting to experiment with AWS, needed a new kind of employee. They didn't need the old-school system administrator who knew how to physically rack a server. That job was now done by Amazon. They didn't just need a software developer who could write application code. They needed someone who could do both. They needed someone who could speak the language of these new cloud, Lego bricks. Someone who could write code not just for an application, but to build and manage the entire infrastructure the application ran on. This was the birth of the cloud engineer, the birth of the DevOps professional, the birth of the cloud solutions architect. And because AWS was the first, and for years the only real player in the game, the demand was hyper-specific. Companies weren't just looking for cloud people. They were desperately searching for AWS people. The supply of these experts was microscopic. You had maybe a few thousand people in the entire country who truly understood how this new world worked. The demand, however, wasn't a trickle. It was a tsunami. Tens of thousands of companies were all trying to hire from the same tiny talent pool at the exact same time. It was a perfect storm of economic forces. An entirely new essential skill set was created almost overnight. The supply of that skill was nearly zero, and the demand for it was practically infinite. When that happens, the price for that skill, the salary you can command, doesn't just go up. It detonates. Amazon didn't just build a new business unit to make more money. They inadvertently created an entire new industry, a new way of building technology, and in doing so, they lit the fuse on the salary explosion that would define the next decade of tech. But Amazon wouldn't have the playground to themselves for long. While the world was marveling at this online bookstore's new trick, the sleeping giants of the tech world were beginning to stir. They had been publicly dismissing the cloud, but behind closed doors, a sense of panic was setting in. And what they did next would pour gasoline on the fire that Amazon had already started. The initial reaction from the established titans of tech was a mix of denial and derision. Larry Ellison, the famously bombastic CEO of Oracle, publicly mocked the entire concept. He joked, What the hell is cloud computing? He called it water vapor and complete gibberish. To him, and many others in the old guard, Amazon was just a bookstore selling a glorified version of the same remote computing services they'd been offering for decades. They couldn't have been more wrong. While they were laughing on stage at conferences, their own engineers and, more importantly, their biggest customers, were quietly swiping corporate credit cards to spin up servers on AWS. The data was undeniable. A revolution was happening, and they were being left behind. The laughter stopped. The panic started. The first giant to truly awaken was Microsoft. For years, Microsoft had dominated the enterprise world. Their Windows Server operating system and SQL Server database software were the bedrock of corporate America. They were a cash-printing machine, a fortress of profitability built on selling software licenses. But a new CEO, Satya Nadella, saw the existential threat. He realized that the cloud wasn't just a new feature. It was a new gravity, one that was pulling the entire world of technology into its orbit. If Microsoft didn't develop its own powerful center of gravity, it would simply become a forgotten satellite. So, in one of the most audacious corporate pivots in modern history, Nadella bet the entire company on the cloud. He declared a new mantra: cloud first, mobile first. This wasn't just a marketing slogan. It was a declaration of war on their own legacy. He told his teams to build a cloud platform which would be called Azure that was so good, it would make their own incredibly profitable server software obsolete. Imagine that. It's like telling your goose that lays golden eggs to start laying platinum ones, knowing it might kill the goose in the process. They began a frantic, all-out effort to catch up to Amazon. They poured billions of dollars into building data centers. They retrained, restructured, and reoriented their entire global sales force. Instead of selling a software license for $100,000, they were now teaching them to sell a $5 an hour virtual machine. It was a brutal, painful transformation. And to make it work, they needed an army of engineers who understood how to build and operate services at a global scale. The problem was, almost all of those engineers already worked for Amazon or Google. Speaking of Google, they were the sleeping giant. Internally, Google had been running its own private cloud for nearly a decade. Their infrastructure was, in many ways, years ahead of what Amazon was offering to the public. They had mastered the art of managing millions of servers, processing exabytes of data, and running applications with near-perfect reliability. They had literally written the book on it, but they had a blind spot. They saw it as an internal tool, a competitive advantage for their search and ads business, not as a product to sell to others. They were engineers building for engineers, not a business building for customers. By the time they finally woke up and launched the Google Cloud Platform, or GCP, they were years behind AWS and the rapidly accelerating Microsoft Azure. But Google had two things the others didn't: arguably the most talented engineering workforce on the planet and a near infinite amount of money. So they did what Google does best. They threw an astonishing amount of resources at the problem. They started hiring top-tier talent not just in engineering but in sales and marketing, trying to build a true enterprise business from scratch. They focused on their strengths: data analytics, machine learning, and an open-source technology they created called Kubernetes, which was quickly becoming the standard for managing modern applications. Suddenly, the landscape had changed completely. It was no longer Amazon versus a handful of tiny startups. It was a three-way heavyweight brawl between Amazon, Microsoft, and Google. Three of the wealthiest, most powerful companies in human history were now locked in a desperate, existential struggle for control of the future of computing. And the primary battlefield for this war was talent. This is the moment the salary explosion truly began. It started with a simple, brutal economic equation. The demand for cloud talent had just tripled overnight, but the supply of people who actually knew how to do this stuff was vanishingly small. We're talking about a few thousand people in the entire world who had real, hands-on experience building and running these hyperscale systems. A feeding frenzy began. Recruiters from Microsoft would camp out in coffee shops near Amazon's Seattle headquarters, armed with offer letters that were impossible to refuse. A senior engineer at AWS making $300,000 a year would get a call from a Microsoft recruiter. The offer? $450,000, a massive signing bonus, and a promotion to principal engineer. They'd take the job. Then, 6 months later, a recruiter from Google Cloud would call them. The new offer? $600,000 in total compensation, a leadership role, and the chance to work on cutting-edge AI infrastructure. This wasn't just poaching. It was a corporate arms race where the ammunition was human capital. The salary figures became dizzying. Stock grants, once reserved for top executives, became standard issue for mid-level cloud engineers. Signing bonuses swelled from $10,000 to over $100,000 just for walking in the door. The companies had no choice. The cost of not having the right engineer was far greater than the cost of overpaying them. A single, brilliant distributed systems engineer could design a feature that would attract a billion-dollar customer. A top-notch solutions architect could go into a Fortune 500 company and convince them to move their entire IT infrastructure to Azure instead of AWS, a deal worth hundreds of millions of dollars over its lifetime. These employees weren't cost centers, they were profit-generating machines. And this created a massive ripple effect. To stop their best people from leaving, Amazon, Microsoft, and Google had to preemptively raise salaries and stock awards across the board. If a new hire was coming in at a certain level, they had to adjust the compensation for everyone already at that level to keep them happy. This feedback loop sent salaries spiraling upward at a rate never before seen in the tech industry. It also created a chasm. The skills required were not something you could learn in a traditional 4-year computer science degree. University programs taught algorithms and data structures, but they didn't teach you how to provision a global network, secure a multi-tenant database, or debug a distributed system that's failing in 3 different time zones. This was a new trade, a new discipline forged in the data centers of these tech giants. The supply of talent wasn't just limited, it was barely being created. You couldn't just go out and hire a cloud engineer. You had to find a great software engineer and then spend a year training them, or you had to steal one from your competitors. The war between the tech giants was just the epicenter of the earthquake. They were fighting over the elite architects and engineers who could build the cloud platforms themselves. But the real shockwave, the one that would create hundreds of thousands of high-paying jobs and change the career trajectory of millions of Americans, was about to hit every other industry on the planet. The banks, the retailers, the healthcare providers, the car manufacturers, they were all about to realize they were facing a choice: get on the cloud or get left behind. And that's when the demand for cloud talent, and their salaries, went from merely astronomical to something else entirely. The choice was brutal and it was binary. It was no longer a strategic advantage to be on the cloud, it was a fatal disadvantage not to be. This wasn't a gentle current pulling the business world in a new direction. This was a flash flood. A paradigm shift so violent and so sudden that it ripped the foundations out from under entire industries. Companies that had spent a century building their empires on physical infrastructure, on server rooms humming in the basements of their skyscrapers, woke up to find they were living in castles made of sand, and the tide was coming in. This triggered what historians will one day call the Great Digital Migration. It was a mass exodus of unprecedented scale. Trillions of dollars in corporate value, petabytes of sensitive data, the entire operational logic of the American economy, all of it had to be moved from private on-premise data centers into the public cloud. And it had to be done yesterday. Think about that. It's not like moving files from one folder to another. It's like taking every single brick from a hospital in New York City and using them to rebuild that exact same hospital in the sky, while it's still performing open-heart surgery. It was chaotic, it was terrifying, and it was a gold rush. Because to perform this kind of magic, to re-architect the guts of a Fortune 500 company in real time, you needed a new kind of wizard. You needed people who understood this new world of distributed systems, of ephemeral computing, of infrastructure as code. The problem was, these people barely existed. Universities weren't teaching it. The curriculum was still focused on the old way of doing things. The vast majority of the existing IT workforce, brilliant as they were experts in a paradigm that was becoming obsolete overnight. They were blacksmiths in the age of the Model T. Suddenly, a chasm opened up in the job market. It wasn't a gap, it was a canyon. On one side, you had every major company in America, from Wall Street banks to Midwest manufacturers, all desperately needing to migrate to the cloud to survive. On the other side, you had a tiny, almost mythical tribe of engineers who actually knew how to do it. The laws of supply and demand, the most undefeated force in economics, took over. And they did so with a vengeance. This is when the poaching wars began. It started with the apex predators, the FAANG companies Facebook, Amazon, Apple, Netflix, and Google. They had been born in the cloud. They understood its power better than anyone, and they had the deepest pockets. They started throwing money at the problem with a ferocity that the market had never seen. An experienced cloud engineer working at, say, a large insurance company in Hartford, Connecticut, making a respectable $140,000 a year, would suddenly get an email from a recruiter at Google. The offer? a $300,000 base salary, a $100,000 signing bonus, and $400,000 in stock vesting over 4 years. Their total compensation didn't just double, it quadrupled. Overnight, the engineer hadn't learned a new skill in the last 24 hours. They were the same person, but the market's valuation of their skills had fundamentally, seismically shifted. And this was just the beginning, because when Google, Amazon, and Microsoft hire someone, they don't just take one person out of the market. They create a vacuum. The insurance company in Hartford now has a critical role to fill, and no one to fill it. So what do? They have to go poach someone from a smaller regional bank. And to do that, they have to beat their salary, so they offer $220,000. Now the regional bank has a vacancy, so they have to poach someone from a local manufacturing company, offering $180,000. This cascade effect rippled through the entire economy. It didn't matter if you were in tech, finance, healthcare, or retail. You were now competing for talent with Google, and you were losing. The only way to keep your best people was to pay them what the market, now dictated by big tech, said they were worth. Salaries weren't just rising. They were being dragged upwards, kicking and screaming, by the gravitational pull of Silicon Valley. Companies quickly realized they weren't just paying for a person who could code. They were paying for a force multiplier. A single brilliant cloud architect could design a system that would allow 500 other developers to build and ship products faster, more securely, and more reliably. They could architect a data platform that unlocked insights, saving the company tens of millions of dollars a year in operational costs. They weren't just an expense on a spreadsheet. They were a revenue-generating, efficiency-creating asset. Their value was nonlinear. Paying them $300,000 a year was a bargain if they unlocked $30 million in value for the business. And just when it seemed like the demand couldn't possibly get any more intense, a once-in-a-century event threw a tanker of gasoline on the fire. The year 2020, the pandemic hit, the world shut down, and in the span of about 30 days, every business continuity plan, every 5-year digital transformation roadmap, was thrown out the window. The future arrived all at once. Overnight, the entire white-collar workforce went remote. The flimsy on-premise VPNs that companies used for a few dozen traveling salespeople suddenly had to support tens of thousands of employees, all streaming video, all accessing critical systems from their home Wi-Fi. The old infrastructure buckled and broke. The only solution? The cloud. Companies that were cloud-curious were now cloud-desperate. Consumer behavior changed instantly. We stopped going to stores and restaurants, we started ordering everything online. E-commerce traffic exploded. Food delivery apps saw demand skyrocket. Streaming services like Netflix became the central form of entertainment for a world on lockdown. Every single one of these services runs on the cloud. The demand for cloud capacity, for engineers who could scale systems to handle this unprecedented load, went from critical to existential. If your app crashed, you didn't just lose a customer. You lost them to a competitor whose cloud infrastructure held up. The C-suite, which for years had viewed the cloud as a complex IT cost center, finally got it. They saw it with their own eyes. The cloud wasn't about saving money on servers. It was about business agility. It was about survival. It was the business itself. The CEO, the CFO, the board of directors, they were all now signing off on massive cloud budgets, telling their teams to hire whoever you need, pay whatever it takes. The floodgates of spending were thrown open, and at the other end of that fire hose was the cloud engineer, whose salary was now being propelled into the stratosphere by the combined forces of technological disruption, corporate warfare, and a global pandemic. The stage was set, a perfect storm of a paradigm shift, corporate desperation, and a worldwide crisis had created a gold rush for a very specific type of talent. But this wasn't just about knowing how to configure an AWS S3 bucket or spin up a virtual machine in Azure. A new kind of professional was being forged in this fire, commanding salaries that broke all the rules of corporate compensation. And what they were selling wasn't just a technical skill. It was a strategic superpower. This superpower wasn't about typing code faster or fixing printers. It was the power to fundamentally reshape a business from the inside out. For decades, the information technology department was what accountants call a cost center. It was a line item on a budget, a necessary expense like electricity or rent. The goal of the IT department was to keep the lights on and, most importantly, to not spend too much money. They were the guardians of the server room, the people who said no to new projects because the hardware budget was already maxed out. They were seen as a drag on innovation, not a driver of it. Cloud computing flipped that entire equation on its head. Suddenly, a small team of skilled individuals could do more than just keep the lights on. They could build an entirely new power grid. They weren't a cost center anymore. They became a profit center. They were the engine of growth. Think about it this way. A traditional company wanting to launch a new app would have to spend months and millions of dollars buying servers, setting up networks, and hiring staff just to get to day one. A cloud-native company could have a single cloud architect design a system that could handle 10 users on Monday and 10 million users on Tuesday, paying only for what they used. That wasn't just saving money. That was enabling a speed and agility that was previously impossible. This is the strategic superpower. The ability to give a business the reflexes of a startup, no matter its size. And the people who wielded this power? They weren't just employees, they were force multipliers. A single brilliant DevOps engineer could create an automated pipeline that takes a developer's idea and deploys it to the world in minutes, not months. That one person's work doesn't just make them productive. It makes hundreds of other developers exponentially more productive. It unlocks the creative potential of the entire organization. A company's C-suite started to realize that hiring one $200,000 a year cloud architect wasn't an expense. It was an investment that could unlock $20 million in new revenue, or save $10 million in operational costs. The return on investment was astronomical. When one person's salary can be directly tied to an 8-figure impact on the bottom line, the old corporate salary bands don't just bend, they shatter completely. This created a frantic, desperate scramble for talent that the American corporate world had never seen before. The demand for people who could truly understand and implement this new paradigm exploded overnight. But the supply was microscopic. You couldn't just go to a 4-year university and get a degree in cloud architecture. This knowledge wasn't in textbooks, it was being forged in the real world, on the front lines of companies like Netflix, which was famously re-engineering its entire infrastructure on AWS. The people who had this knowledge were a tiny elite group who had taught themselves, who had failed and learned and built systems that were now the envy of the world. And so began the great cloud gold rush. But instead of digging for metal in the ground, companies were digging for talent. They weren't just looking for an IT guy. They were looking for very specific, very rare combinations of skills. They were looking for unicorns. They needed the cloud architect, the grand designer who could look at a complex business problem and sketch out a blueprint for a resilient, scalable, and cost-effective solution in the cloud. This person had to be a master of networking, storage, computing, and databases, all while thinking like a CFO. A single bad architectural decision could cost a company millions of dollars in wasted cloud spend, while a good one could become a legendary competitive advantage. Then they needed the DevOps engineer. This wasn't a developer, and it wasn't an operations guy. It was a hybrid, a new breed of engineer who automated everything. They built the software factory, the invisible machinery that allowed a company to release new features continuously and reliably. In a world where speed is everything, the DevOps engineer was the one building the superhighways. They were the difference between being a market leader and a market follower. And of course, they needed the cloud security specialist. As companies moved their most sensitive data, their customer lists, their financial records, their secret formulas, into the cloud, they created a massive new target for hackers. A single data breach could destroy a company's reputation and cost it hundreds of millions in fines and lost business. The cloud security specialist was the digital Praetorian Guard, tasked with defending this new kingdom in the sky. Their job wasn't just to prevent disaster. It was to enable the business to move forward with confidence. Finding someone who was an expert in just one of these areas was hard enough. But the real magic, the real salary explosion, happened when you found someone who understood all of them. The person who could architect the system, build the automation to run it, and design the security to protect it. That person wasn't just a unicorn. They were a golden goose. And every company in America suddenly wanted one. It wasn't just the tech giants in Silicon Valley. It was Walmart trying to compete with Amazon's e-commerce machine. It was Goldman Sachs, moving its trading platforms to the cloud to gain a millisecond edge. It was Johnson & Johnson, using cloud-based AI to accelerate drug discovery. It was Ford building connected car platforms that stream terabytes of data every single day. This national cross-industry demand created a bidding war of epic proportions. A talented cloud engineer working at a bank in Charlotte would suddenly get a message on LinkedIn from a recruiter at Google, offering a 30% raise and a $50,000 signing bonus. Before they could even respond, a message would come in from a stealth startup, offering stock options that could be worth millions. Their current employer, terrified of losing the one person who understood their critical systems, would come back with a massive counteroffer. Salaries were no longer determined by HR departments and compensation bands. They were determined by the raw, brutal forces of supply and demand in an open market. It was corporate trench warfare for talent, with salaries, bonuses, and remote work packages as the weapons. The numbers became staggering. Senior cloud architects regularly clearing $300,000, $400,000 a year. Principal engineers at top tech firms pushing past $500,000 in total compensation. And these weren't executives with corner offices. These were hands-on keyboard engineers, individual contributors whose strategic value was so immense that companies were willing to pay them more than most of their vice presidents. This wasn't a bubble. It was a fundamental repricing of value in the American economy, a recognition that the people who build the digital infrastructure, upon which modern business runs, are the new kingmakers. And this is where the story gets truly interesting. Because if you think the last decade was a gold rush, you haven't seen anything yet. The explosion in cloud salaries we've witnessed so far. That was just the appetizer. We're now entering the main course, and the forces driving demand are about to go into overdrive. The first and most powerful is the single biggest technological shift of our generation: artificial intelligence. Every company, from Wall Street banks to Midwest farming conglomerates, is now scrambling to become an AI company. They're desperate to leverage machine learning for everything from predicting stock prices to optimizing crop yields. But here's the secret they don't tell you in the flashy keynote presentations. AI is a ravenous beast. It consumes astronomical amounts of data and requires computational power that makes the old IT world look like a pocket calculator. And where does this beast live? Where is it fed, trained, and unleashed? In the cloud. AI models don't just run on a spare server in the back office. They require specialized GPU instances, massively parallel processing, and intricate data pipelines that can handle petabytes of information in real time. Building, managing, and scaling this infrastructure is not a job for a traditional IT guy. It's a job for a cloud architect who understands the nuances of AWS SageMaker or Google's Vertex AI. It's a job for an ML ops engineer who can build a system that automatically retrains and deploys models without a human ever touching a button. These aren't just IT jobs anymore. They are the core engine of a company's competitive advantage. And the demand for people who can build that engine is growing at an exponential rate, while the supply of talent is growing linearly. Basic economics tells you exactly what that does to salaries. But AI is just one part of the equation. The second massive driver is happening at the opposite end of the spectrum: edge computing. For years, the cloud meant centralizing everything. We pushed all our data and all our processing into these massive hyperscale data centers. Now the pendulum is starting to swing back. Think about a self-driving car. It cannot afford to send sensor data to a data center 1,000 miles away, wait for a decision, and get it back before deciding whether to brake. The latency would be fatal. That decision has to be made right there, in the car, at the edge. The same is true for smart factories, drone delivery systems, and even your local Walmart, which needs to process video feeds to see when to restock shelves. But the edge doesn't replace the cloud. It extends it. The edge devices do the initial, time-sensitive processing, but they still need to sync with the central cloud for large-scale analytics, model updates, and long-term storage. This creates a mind-bendingly complex hybrid environment. How do you manage and secure millions of tiny distributed computers as if they were one cohesive system? How do you deploy software updates to a fleet of 1 million delivery drones simultaneously and flawlessly? The answer is with sophisticated cloud and edge orchestration platforms. And the people who can design and manage these systems are some of the rarest, and therefore most valuable technologists on the planet. This leads us to the third, and perhaps most urgent driver: cybersecurity. The more we move our critical infrastructure, our financial systems, our power grids, our healthcare records, into the cloud, the more attractive a target it becomes. A single well-executed attack on a major cloud provider could have devastating consequences for the national economy. Consequently, the demand for cloud security specialists has gone from important to existential. We're no longer talking about just putting up a firewall. We're talking about zero-trust architectures, where nothing is trusted by default. We're talking about sophisticated identity and access management systems that can handle millions of users. We're talking about engineers who can hunt for threats in real time across a global network and use AI to predict attacks before they even happen. A top-tier cloud security architect isn't just protecting a company's data. They are protecting the company's entire existence. And companies are finally willing to pay for that peace of mind. A salary of $300,000 or $400,000 is a rounding error compared to the billions in market cap that can be wiped out by a single major breach. So you have this perfect storm. The insatiable demand from AI, the expanding complexity of the edge, and the existential need for security. It's a triple threat that ensures the war for cloud talent will only intensify. This brings us to the question that's likely on your mind. Is it too late? Did I miss the boat? The answer is an emphatic no. In fact, we are still in the early innings. The reason is simple. The rate of innovation is not slowing down. Every year, AWS, Azure, and Google Cloud release hundreds of new services. The field is constantly reinventing itself. The skills that were cutting edge 5 years ago are now the baseline. This means there is always a new frontier to specialize in. 5 years ago, nobody had FinOps specialist on their resume, a role dedicated to optimizing a company's cloud spending, which now saves companies millions and commands a huge salary. The role of platform engineer, building internal tools so that hundreds of other developers can work more efficiently, barely existed in its current form. The opportunity is not in learning what everyone else already knows. The opportunity is in skating to where the puck is going. Right now, that means diving deep into technologies like Kubernetes for container orchestration, Terraform for infrastructure as code, and serverless architectures like AWS Lambda. These aren't just buzzwords. They are the fundamental building blocks of modern, scalable, and cost-effective applications. Mastering them isn't just about getting a job. It's about becoming part of the top 1% of practitioners in the field. But more than any single technology, the real key to unlocking these top-tier salaries is a mindset shift. It's moving from being a technician to being a business strategist. The highest-paid cloud professionals don't just know how to build something. They know why. They can sit down with a chief financial officer and explain, in plain English, how migrating to a serverless architecture will reduce operational costs by 40%. They can talk to a chief marketing officer and design a data analytics pipeline that will increase customer lifetime value by 15%. They don't just write code. They solve multi-million-dollar business problems. They are consultants, architects, and strategists who just happen to use technology as their medium. This is the ultimate reason why cloud salaries are exploding in America. It's not about a temporary skills gap or corporate hype. It's a reflection of a fundamental economic truth. The cloud is no longer just the IT department. It is the business. It is the factory floor, the supply chain, the customer relationship, and the engine of innovation all rolled into one. And the people who can build, secure, and optimize that engine are creating more tangible bottom-line value than almost anyone else in the organization. Their compensation isn't an inflated bubble. It's simply the market catching up to the immense leverage they provide. They are the architects of our digital world, and in the 21st century, the architects get paid. The future isn't just being built on the cloud, the future is the cloud. And its architects are just getting started.